So we have been discussing about the different configurations of microassembly. In fact, we had discussed a lot about this manual and automated based system. So automated based microassembly. So we have seen some different configurations related to this microassembly. Now in today's lecture, so we will discuss about this hybrid based microassembly. So as the name suggests that, so this hybrid is basically a system that integrates both manual and automated microassembly process. So one of the key importance includes it reduces the assembly cost, it accommodates fluctuating production demands and enables both prototyping and small to mid volume production. So these are some of the key importance of this system. So as far as this application areas perspective point of view, like these are automotive, it is highly used for automotive sensor related applications. It is used for medical kind of microfluidic devices, and it is also used for kind of a telecommunication related applications. Now this will give us a kind of a fundamental with reference to a manual mode and an automated mode. So as far as some of the key components of this hybrid microassembly systems are concerned, it's a kind of a teleoperated system. So in this teleoperated system, it provides a high precision manual control, and it uses a force feedback control and a high resolution cameras. As far as this automated assembly systems are concerned, it uses a sensor and a robotics and a computer control for an efficient production perspective point of view. So ideally it includes a kind of a modular micro gripper and a positioning system. And as far as vision based feedback systems are concerned, so it has a kind of an integrated CCD camera with telecentric lenses for accurate alignment. So ideally kind of a autofocus kind of systems will be enabled. Now if we try to look into the overall configuration of this particular manual mode system and an automated system, so we have different subsystems which are participating in this particular hybrid microassembly. So one system basically includes the haptic and the graphic user interface. So this haptic and the graphic user interface normally communicates with the teleoperated subdomains as well as the other subdomains. So as far as in this teleoperated subdomains, we have the force sensor in place. We have a Cartesian coordinate, a kind of a camera which is used as a kind of a processing an image, capturing the image for processing the image as well as giving a feedback to the appropriate system. Now if we try to look into the overall aspect, so we have the automation controller in place, then there is a programming GUI, and then there is a forced feedback control sticks which are available. So ideally there will be an interaction between the manual mode and an automotive mode based on the requirement. So as far as in this manual teleoperated mode is concerned, so it is used for prototyping and small batch production. Some of the key features basically includes a kind of a operator control where a kind of a micro manipulation happens with reference to a joystick, and it has a kind of a real-time force feedback which compensate for scaling effect. It also has a kind of a cameras which provide a multiple views for precise control. As far as automated mode is concerned, it is used for a larger production volume. Some of the key features basically includes the pre-programmed microassembly steps. It used a kind of a closed loop feedback from the sensor and a kind of an AI based adaptive control for precision adjustment. So these are some kind of automated mode system. Now let us discuss one of the key aspect of this a kind of a case study for in the case of a micromanipulation stage. So when we try to look into this micromanipulation, we can classify this micromanipulation into two. One is called as a serial based manipulation. Other one is called as a parallel based manipulation. So in the case of a serial based manipulation, there are some systems are there where it has a kind of an integrated arrangement and the overall end effectors are placed over here. So this is a kind of a manipulation arrangement which exists. So this is a kind of a complete micro robotic system. So this micro robotic system, like as far as this particular serial manipulation is concerned, with serial manipulation, it is deployed for measurement related applications, or it is deployed for it has a kind of a needle. Through the needle we can do a kind of a micro manipulation which exhibits over here. So here, for the overall movement perspective point of view, we can have a kind of a stick slip phenomenon. So if you remember, we have discussed about the stick slip phenomenon, where we will be having a leg kind of arrangement. This leg will move back and forth. So when this leg moves back and forth, appropriately you can see a kind of a movement in the system. So like it's a kind of a ploughing behavior which exhibits. So this ploughing behavior will catalyze the movement of this stage or the manipulator. So this is a kind of a stick slip based phenomenon which exhibits towards the kind of a serial manipulation. So as far as in this serial manipulation, since the manipulator is connected in series, that is why it is called as a serial manipulation. Such kind of manipulations are effectively used for locomotion perspective point of view, like locomotion of end effector or precise manipulation of end effector perspective point of view, where such kind of stick slip phenomenon can be deployed. So these stick slip phenomenon are actuated either through a piezoelectric system, or it is actuated through a magnetic based system. Okay, so this is a kind of a serial manipulator based end effector. Now let us discuss about a parallel manipulator based micro manipulation. So in the case of parallel based micro manipulation, this is a kind of an arrangement which exhibits, and this is used for the movement of the system. So as far as in this particular case is concerned, we can have a multiple orientation. For example, this is a kind of a SMA biomorph based actuator. Okay, so the actuation is happening to have a kind of a manipulation on the top. So ideally we try to take the axis over here. So with reference to this axis, we can have a kind of a theta orientation to it, or a kind of an XY movement to it. So either with reference to a theta orientation or with reference to an XY. So appropriately we can program this system for a kind of theta or XY orientation for either for a beam steering or for certain amount of micro manipulations also. Or in certain cases this configurations can also be deployed something like this. And over this we can have another stage. So the overall manipulation which exhibits over here in this bimorph will be in this particular direction. So when you try to actuate it, it will try to expand in this particular direction. When there is an expansion is there, appropriately there will be a orientation along the XY, along the X and the Z plane for the manipulation perspective point of view. There are manipulations where both serial plus parallel are deployed. In such kind of manipulations, so most of you might be aware about this Stewart platform. So this is a kind of a Stewart platform kind of arrangement. Over this Stewart platform there is going to be an end effector. So there is going to be a movement in the Stewart platform, and this is a kind of a parallel manipulator which moves in an appropriate orientation. So based on the requirement, so like we will be having 2 to 3 sets of manipulation. So one manipulation is happening along the like a XYZ plane, and the other manipulation is happening along the end effector plane. Okay, so these are some of the different sub micro manipulation stages which are effectively used for different functional applications based on the character. So ideally, like such kind of micro manipulation stages, so it exists in the range of more than 1 micrometer. However, it is more to do with the manipulation range. Okay, so there is a precise control of this manipulation range, and the control of this manipulation range is well interfaced with reference to the actuator what we are using. So ideally in most of these cases, so as I had mentioned earlier, here we are using a piezoelectric or kind of a like magnetic based system, so that there is a kind of a precise manipulation is recorded. As far as in this particular case is concerned, so we are talking about a shape memory alloy which will have a precise control over the orientation as well as over the axis. Now let us discuss about the different key parameters or different micro operation based platforms which are available in the literatures. So one is a kind of an hexapod. So as far as these hexapods are concerned, it has a degrees of freedom in x, y, z plane, and it also has a degrees of freedom in theta x, theta y and theta z. The overall envelope is in the range of 100 mm to 180 mm is the overall work envelope, that is the degrees of freedom size. When we try to look into the resolution perspective point of view, along the xy plane it is in the order of 200 nanometers, and in the case of z plane it is around 80 nanometer. With reference to theta perspective point of view, it is in 2.5 microradians, and then with reference to xy plane it is around plus or minus 17 mm, and at z it is around 6.5 mm, and along the theta x and theta y it is around 10 degrees, and along theta z it is around 21 degrees. So it is a kind of a open loop system, so that is why the overall range is crossing more than 10 mm, and then the overall repeatability perspective point of view, it is like plus or minus 0.06 micrometer is the overall repeatability of this hexapod. Now there is a kind of a smart prod which is available. So this smart prod is a kind of a closed loop system. It has a higher order repeatability. So when we look into the overall degrees of freedom perspective point of view, it is 110 mm and 45 mm, and then xyz is around 1 nanometer, which is of high precise, and theta is 3 micrometer degrees, and the xy plane is plus or minus 10 mm and z is plus or minus 5.5 mm. Theta x and theta y are plus or minus 13 degrees, and theta z is 19 degrees. There are few n probers are there. So as far as n probers are concerned, n into this particular probe movement, so it's a kind of an open loop system. It has a repeatability close to around 0.05 micrometer, and it has a kind of 2 bar 100 nanometer is the overall resolution. So its xyz is in the range of 12 mm and it is around 28 mm. It's slightly a kind of a prober which is used for a manipulation perspective point of view. In fact, so it's a kind of a serial manipulator with an appropriate actuators which are being established in these n probers. So this MM3AM is also focused upon the xyz and theta z. It's a kind of an open loop system which has a repeatability less than 2, and PS8E is a very specialized micro operation platform which are available. Now in addition to this, there are other platforms like ANSXYZ, so which has a kind of a resolution of 0.03 mm and 0.0043 mm, and it has a life force. There is a kind of a life force based micro operation platform which has a kind of degrees of freedom in the XYZ plane with 127 mm and 127 mm and 30 mm, which is slightly on a macro scale. However, the resolution is in the order of few nanometers, and the XY plane is restricted to around 10 mm. So it has a very restricted plane, and a good part of it is it has a very good closed loop system with a high repeatability of close to around 0.001 micrometer. There are few hybrid hexapods are there. So these hybrid hexapods has a kind of a orientation in XYZ plane, as well as it has a orientation in theta x, theta y, and theta z. The resolution is in the order of few 5 nanometers, and it has x and y and z with theta x and theta y with plus or minus 30 degrees and theta z is 360 degrees. So it has a kind of a closed loop with a repeatability less than 0.08 micrometer and a drifting system. So Imina is also a kind of a small micro operation platform which has a kind of T, X, Y, Z and a theta Z, and it has a kind of 20.5 mm and 22 mm and 12.5 mm. It has an open loop system with a good repeatability and drift is less than 1 nanometer. So now, the overall microassembly perspective point of view, so when we try to categorize these microassemblies, so we try to categorize these microassemblies under different features. One is with reference to the flexibility, second one is with reference to the overall production volume, third is with reference to the overall precision of this particular system, the cost which is involved, and the automation level. A flexibility perspective point of view, on a manual mode we have a high, whereas on an automated mode it has a low. And a production volume perspective point of view, it is small, and an automated it has a larger system, which is one of the key aspect which results in reduction in flexibility. Precision perspective point of view, it is in manual mode, and in the case of an automated mode it is moderate. Cost perspective point of view, it's high cost per unit and it's a low per unit, and an automation level perspective point of view, it is low and high. So some of the key takeaways from these microassembly of Microrobotics concern, these hybrid microassembly enables both prototyping as well as mass production. It reduces the cost and transition time between the manual and the automated process. So as far as future improvement perspective point of view, it will enhance the adaptability and efficiency based on the characteristics. Now let us discuss about the different micro challenges which are being evolved with reference to this microassembly perspective point of view. Now when we try to address these challenges, so one is simple and practical. So the appropriate choices for establishing a kind of a simple and a practical actuation perspective point of view is a kind of a magnetic field, magnetization and the manipulation equipments are relatively mature. However, an inappropriate choice with refers to simple and perspective is a mechanical gripper, which requires an open space, mostly requires a kind of a bulky controller. Next, with reference to a kind of a micro object perspective, typical micro object perspective point of view. So these mechanical grippers have high precision, it has a high degrees of freedom, and it is mainly meant for selective operation. However, acoustic perspective point of view, it is very difficult to control the micromanipulation. So that is one of the major drawback of acoustic field. So basically, acoustic field of special shaped objects, it is difficult to isolate the irrelevant part. With reference to feedback in the closed environment perspective point of view, so these mechanical grippers, it has a possibility of integrating with microsensors. So all the field based methods, mainly based on the visual feedback or other information feedbacks, are highly limited. With reference to autonomy perspective point of view, these mechanical grippers have high accuracy and diverse information feedback, whereas the inappropriate choices basically includes a field based method where automation is completely a kind of a vision based system, which is highly limited, limited but feasible. Safety concerns perspective point of view, special modifications are required, and there is almost no thermal effect can be considered. Now magnetic field and light field magnetization is required, and the photothermal effect is a kind of an unavoidable process. Okay, so to give you an overview about these microassembly, so we had discussed about the different configurations of microassembly. So ideally we had discussed about the different losses through which these microassemblies are governed. So we had discussed about the surface tension, we have discussed about the van der Waals forces, we have discussed about the electrostatic charges, we have also had a discussion about surface tension and gravity, and what are the different subsystems which are participating for creating such kind of environment or the characteristics. So we also had some discussion about the different building blocks and the techniques which are being evolved. So under the building blocks, we have discussed about microparticle, multiple objects, and the cells. And technique perspective point of view, structure construction, MEMS operation, and biomedical engineering. And we had discussed about the different applications. So one of the application was the magnetic field, the optical field, the acoustic field, and the mechanical operations. Characteristics perspective point of view, as far as magnetic is concerned, we are discussing about the key features and the technologies and applications. It has a wider applications and it is highly focused towards the targeted drug delivery. So we had discussed about the mechanical, optical, and acoustics. So optical and acoustics has a wider application in biomedical related domain. And then we also had some discussion about the overall approaches as far as gripper based microassembly is concerned. What are the different forces which exerts on these gripper based microassembly? So we had some discussion about the different parameters which are impacting on the electrostatic force, especially on a micron level for micro gripping perspective point of view, van der Waals forces and the hydrophilic forces. So it's a kind of a consolidated features or a consolidated influence parameters perspective point of view with reference to force and an object radius. So we had a discussion about the serial microassembly, a parallel microassembly, overall comparison between the serial microassembly and a parallel microassembly. The stochastic based microassembly, basically it's a kind of a self-assembled system, how it is being connected. And then we also had a discussion about this directed microassembly, the capillary and the magnetic based micro robots which exhibits. So we also had a discussion about this magnetic assemblies with arbitrary geometries. So we took an example where there is a kind of a magnetic micro robot is there. It is self propelled using a kind of a magnetic field and the optical field. So it has a two component, Fe2O3 and TiO2, alpha TiO2. So alpha TiO2 is coated on the Fe2O3. So this Fe2O3 it is manufactured through a hydrothermal process, and TiO2 is through an ALD, so that it becomes a kind of a subsystem for a micro robot, and these subsystems are assembled by applying appropriate magnetic field as well as a kind of a light propagation. So there are three different stages are there. One is a kind of a photoretic interaction, and another one is a kind of an active cluster generation, and third is a kind of a magnetic dipole interaction, which is resulting in a kind of a self-assembled system. And these self-assembled system highly participates in the kind of a photocatalytic reaction. So we have made a comparison with respect to direct microassembly and traditional microassembly, and then we also had some discussion about this hybrid microassembly, where we had included where it's a kind of a combination of both manual and automated system. How these what are the different subsystems which are participating with reference to this manual and the automated system, what are the different key features, how it is being calculated. And as far as micromanipulation stages perspective point of view, so we can classify it in the form of a serial manipulation, a parallel manipulation. We can also consider a hybrid manipulation, which involves both for an appropriate functionality. As far as serial manipulation is concerned, so we have taken the case study in which a kind of a serial manipulator, which is a kind of an end effector which is placed, and the movement or the manipulation actuation is happening because of the piezoelectric effect. As far as this parallel manipulation is concerned, these shape memory alloy structures are integrated with the structure. By actuating these shape memory alloy structures, there is going to be a deflection, and these deflection can be efficiently recorded. So there are different micro operation platforms which are available. So this chart will give a overall characteristics about whenever we are designing a kind of a micro operation platform, what are the different degrees of freedom which exhibits, what are the different motion ranges which exhibits, and what are the different control loops which exhibits over here. So we also had a discussion about this manual mode and an automated mode, and we also had a discussion some of the key challenges which are evolved with reference to microassembly perspective point of view. One of the challenge includes simple and practical, and beyond the typical micro object, information feedback, the level of autonomy, and the safety concerns are discussed. So in the upcoming classes, we will be discussing about the micro aerial robots, micro aerial vehicles, how these micro aerial vehicles are designed and how it is being, what are the different classifications which are evolved in it in detail in the upcoming lecture.